Hello everyone, this is Marian Piquipiabo, a Master's of Business in Administration 1. So today I'm going to discuss to you the critical path method and networking schedule. At the end of the discussion, we will learn how to construct a CPM network to determine the critical path in project completion time and to compute the total floats and free floats for non-critical activities. But before that, first let me explain the basic concept of what is project management, what are the phases of project management, the guidelines for network constructions, and the critical path. So project management. A project consists of interrelated activities which are to be executed in a certain order before the entire task is completed. So a project means it has different activities, and each of every activities are interrelated with each other. So the activities are interrelated in a logical sequence which is known as precedence relationship. So precedence relationship means, for example, if you take one particular activities, if you take one particular project, it has different activities. Like for example, activity A, B, C, D, and so on. So after completing activity A, only you can be able to move to activity B. So now we have a relationship between activity A and activity B, and that relationship is called a precedence relationship. So a project is represented in a network form in order to find the solutions for scheduling and controlling its activities. So in project management, it has two basic techniques: the CPM or the critical path method, or the PERT or the project evaluation and review techniques. But in this discussion, we will only focus on the CPM. Now move to the phases of project management. The phases of project management are planning, scheduling, and controlling. So in planning, it's dividing the project into distinct activities, estimating time requirements for each activity, establishing precedence relationship among the activities, and the construction of arrow diagram, or what we call the network construction. So these are the different path and planning activities. So in scheduling, determines the start and end time of each and every activity, and in controlling, it uses the arrow diagram and time chart for continuous monitoring and progress reporting. So these are the phases of project management. Now let's see the guidelines for network construction. So the first guideline: the starting event and ending event of an activity are called tail event and head event respectively. So now let's see our network construction. So this is our network construction. So you have different activities. So this thing, 1, 2, 3, those are the things called nodes. And the A, B, C, D, those are your different activities in the network construction. So the first guideline is the starting event and ending event of an activity are called tail event and head event. So the first one here is the tail event, and the completion event here is the head event. So in order to complete the first activity, which is the activity A, we need to have two nodes, 1 and 2. Now back to our second and third guidelines. The network should have a unique starting node or tail event, and then the network should have a unique completion node or the head event. And number 4, no activity should be represented by more than one activity in the network. And the fifth guidelines is no two activities should have the same starting node and the same ending node. So look at our network construction. So there will be an activity that ends with, that start with the same nodes and ends with the same nodes, like as you can see. So yes, there is an activity which is start in the same node here, but it ends with the different nodes. So again, there will be no activity to start with the same nodes and ends with the same nodes. And our last guidelines is dummy activity is an imaginary activity indicating precedence relationship only. So duration of a dummy activity is 0. So here. So look at the network. So after completing activity A, then we can move to activity B, C, D. We can move to the following activity. So in the same way, after completing 4 and 5, now we can move to 6. So we have a dummy activity here, the 4 and 5. So a dummy activity is also called an imaginary activity. So for an imaginary activity, there will be no duration for it because this dummy activity indicates a precedence relationship only. So there will be no duration for this dummy activity. So consider this as a detail in a project. So these are the different activities in this column, and in this column are the immediate predecessors. So after we can complete this particular activities, only we can be able to move to this activity here in this column. And this column is our duration. So it is talk about months. So 2 months in activity A, 2 months, B, 5 months. So these are the durations for our different activities here. Now with this information, we are asked to construct the CPM network to determine the critical path and project completion time and compute the total floats and free floats for non-critical activities. So now we're going to construct the CPM network. Now look at the problem here. So the first 3 activity, as you can see, activity A, B, and C, there is no immediate predecessors. So therefore, we can directly begin drawing this particular activity, this A, B, C. So here. So here is the node 1, and then we're going to draw here. And this is node 2, and this is our activity A, which is the duration is 2 months. And our activity B here, another is 5 months, and our activity C is 4 months. So this is our first 3 activity A, B, and C. So remember, for each and every activity, there will be 2 nodes. So as you can see here, 1 and 2, 1 and 3, and 1 and 4. So far, we have done our first 3 activity. Now we'll move to our next activity, which is activity D. So as you can see, an immediate predecessors is given. So activity D is activity B is an immediate predecessors for activity D. It means that only we can after completing activity B, we can move to activity D. In the same way, as you can see, activity B is also an immediate predecessors for activity G here. So therefore, it means that after we complete activity B, we can move to activity D and G. But before you draw activity D, just check whether D ends individually or it ends with any other activity. So for that, we have to verify immediate predecessors. Now look at the immediate predecessors column. So as you can see, C and D are immediate predecessor for H and I, which means that C and D, both of that ends with the same place. So we're going to now draw the activity D. So activity D starts where activity B ends. So here. Oh, sorry. So activity D starts where activity B ends. So B ends here. Therefore, we have to start here and end with here, D, because C and D both ends with the same place. So activity D starts where B ends. So B ends here. So therefore, we're going to start here and ends here, because C and D both ends in the same place in node 4. So far we have done activity A, B, C, and D. Now we're going to move to activity A. So activity E is here. So an immediate predecessor is already given, activity A. Therefore, activity E will start where activity A ends. So again, before we're going to draw the activity, we have to check in immediate predecessor column if that particular activity will end separately or with any other activity. So as you can see here, E is an immediate predecessor for activity J, and it ends separately. So therefore, this is independent activity. So it ends in separately. Now, we're going to move to our network construction. So again, activity E will start where activity A ends. So activity A ends here in node number 2, but therefore we're going to start here. And it ends separately. Now move to the following activity, which is activity F. So in activity F, it starts where activity A ends. So because activity A is an immediate predecessor for activity F, and then we have to check activity F if whether it ends separately or it ends with any other activity. So here, as you can see, F, G, and H ends together, and it is an immediate predecessor for K and L. So here. So F starts where A ends. So here. And also, as you can see here, G starts where B ends, and H starts where C and D ends. And remember that these 3 activities both ends together. So here. So G starts where B ends, here. And H starts where C and D ends. And that activities ends together in node number 6. So now we are done in activity F, G, and H. Now we're going to move to activity I. So activity I starts where C and D ends. And activity I is an immediate predecessor for M. So now we're going to move to the following activity, which is the activity J. So activity J starts where activity E ends. So activity J starts where activity E ends. So activity E ends here, therefore we're going to start here and move our activity J. So our activity L, okay, it starts where F, G, and H ends. And also G and K, take note that it ends both in the same place. Therefore, we're going to start activity K here, F, G, and H in node number 6, and it ends together with both in the same place. So J and K both ends in the same nodes. The activity, in node number 8. So far, we are done our activity from A to activity K. So look at the following 3 activities, the L, M, and N. So these activities are not an immediate predecessor for any other activity, as you can see. So therefore, these three activity are called ending activity, and this activities ends with the same nodes. So L starts where F, G, and H ends. So L starts where F, G, and H ends here. So it starts here, L. And our M starts where I ends. So starts where I ends. I ends here, so it starts here, M. And our last activity, activity N starts where J and K ends. So J and K ends here, therefore we're going to start here and ends with the same nodes. So L, M, and ends with the same nodes, and this nodes is our ending activity. So this is the procedure to draw the CPM network, or the critical path method. So now we're going to move to our second problem, which is to determine the second problem is to determine the critical path and project completion time. But yes, before that, first let me explain what is critical path. So the critical path of the project network is the longest path in the network. So this can be identified by simply listing out all possible paths from the start node of the project to the end node of the project, and then selecting the path with the maximum sum of activity times on the path. So back to our network construction. So this node number 1, this is our starting node, and node number 9, this is our ending node. So now let's find out which path is at maximum duration. So this path is our critical path. In order to find a critical path, we have to follow several rules. There are two phases in finding critical path. First is determine the earliest start time of all the nodes. So this is called forward pass. And second is to determine the latest completion time of the various nodes. So this is called a backward pass. So we need to find these two things in order to find the critical path. So in determining the earliest start times, we are given this formula. The earliest start time of ending activity is equals to maximum of the earliest start time of starting activity plus the duration. And in determining the latest completion time, we have this formula. The latest completion of starting activity is equals to minimum of latest completion of ending activity is minus the duration. So in order to find the critical path, we need to have two squares, the lower square and the upper square. The lower square stands for the earliest start time, and the upper square stands for the latest completion time. So as you can see, I have already computed the latest completion time and the earliest start time. But I am going to discuss to you how I computed it. First, I am going to explain how to calculate the earliest start time. In determining the earliest start time, we are given this formula. The earliest start time of ending activity is equals to maximum of the earliest start time of starting activity plus the duration. So we're going to look here. The earliest start time of an starting activity is always 0. So now we have to find out the earliest start time of an ending activity. And according to the given formula, the earliest start time of the starting activity plus the duration. So 0 plus 2 is equals to 2. So therefore, the earliest start time of our ending activity is 2. Now move to our activity B. So the earliest start time, 0 plus the duration of 5 months is equals to 5. So the earliest start time of our node 3 or the ending activity is 5. Now move to the next activity or the next node. So as you can see there, this node has two options, the 1 to 4 and 3 to 4. And now, according to the formula, we have to choose the maximum value. So here, 0 plus 4 is equals to 4. 5 plus 5 is equals to 10. So therefore, we're going to choose a 10 because the 10 is the maximum value. Move to node number 5. So the earliest start time here is 2 plus 7 is equals to 9. So now move to node number 6. So as you can see, there are 3 options, 2 to 6, 3 to 6, and 4 to 6. So here again, we need to choose the maximum value. So 2 plus 3 is equals to 5. 5 plus 3 is equals to 8. 10 plus 6 is equals to 16. Therefore, we choose 16. So that goes along with the rest of the node. So that is how are we going to compute the earliest start time of our activity. So now I'm going to explain how I computed the latest completion time. Now, if earlier in our computation of the earliest start time, we start at the very beginning, the starting point. Now, the latest completion time, we start at the ending. This computation is called the backward pass. So for the last node, the earliest start time is 28. Now, always remember that the latest completion time of the ending node is always equal to the earliest start time, which is 28. That's why we put here 28, because it should be equal. So in determining the latest completion time, we are given this formula. The latest completion of starting activity is equals to the minimum of the latest completion of ending activity minus the duration. So the latest completion of our ending activity is 28 minus the duration. So 28 minus 8 is equals to 20. So again, we're going to calculate it backward, because this calculation is a backward pass. Now move to the next node, 7. So 28 minus 12 is equals to 16. Next is node number 6. So as you can see, there are 2 options. It's 8 to 6 and 9 to 6. So here, we are going to choose the minimum value. Not the maximum, but the minimum value, because we're going to compute the latest completion time. So 20 minus 4 is equals to 16. 28 minus 3 is equals to 25. Therefore, we choose 16 because 16 is the minimum value. So our next node is 5. So 20 minus 5 is equals to 15. Now move to our next node, 4. As you can see, there are 2 options, 6 to 4 and 7 to 4. Again, we're going to choose the minimum value. 16 minus 6 is equals to 10. 16 minus 2 is equals to 14. That's why we're going to choose 10. 10 is the minimum value. Again, 3. Now we'll move to 3. There are 2 options again. So we have to choose the minimum. 16 minus 3, 13. 10 minus 5 is equals to 5. Therefore, we choose 5. Move to number 2. 15 minus 7 is equals to 8. 16 minus 3 is equals to 13. That's why we choose 8. We'll move to our last node, node number 1. So there are 3 options. So we have to choose the minimum value. 8 minus 2 is equals to 6. 5 minus 5, 0. 10 minus 4 is equals to 6. Therefore, we have to choose 0. 0 is the minimum value. So now we have already calculated our earliest start time and at the same time our latest completion time. So therefore, we can now determine our critical path. In order to find our critical path, we have to consider 3 conditions. So the 3 conditions in finding critical path are earliest start time of a starting activity is equals to the latest completion of a starting activity. And the earliest start time of ending activity is equals to the latest completion of our ending activity. And lastly, the earliest start time of our ending activity minus the earliest start time of our starting activity is equals to duration. And the same way, the latest completion of our ending activity minus the latest completion of our starting activity is equals to duration. So now look here. So according to our first condition, the earliest start time of our starting activity is equals to the latest completion of our starting activity. So the first condition is satisfied. Now move to our second condition. The earliest start time of our ending activity, this is our ending activity, is equal to the latest completion of our ending activity. So as you can see, they are equal. So therefore, the first and 2 conditions are satisfied. Now move to our third conditions. So our third conditions is the earliest start time of ending activity minus the earliest start time of a starting activity is equals to duration. And at the same time, the latest completion of ending activity minus the latest completion of starting activity is equals to duration. Now look, let's see if our third conditions are met. So the earliest start time of our ending activity minus the earliest start time of our starting activity is equals to duration now. So 5 minus 0 is equals to 5. In the same way, the latest completion of our ending activity, 5, minus the latest completion of our starting activity, 0. So 5 minus 0 is equals to duration. 5 minus 0 is equals to 5. So as you can see, all of our 3 conditions are met. Therefore, our critical path here is activity B, which is node number 1 and 3. And the same goes here. This is I already highlighted the critical path. So this is our critical path. 1 to 3, 3 to 4, 4 to 6, 6 to 8, and 8 to 9. So this is the same way here. So the earliest start time and the latest completion time are equal. And then 10 minus 5 is equals to duration, which is 5. So that is the same way. So that, how are we going to find our critical path? So our critical path is 1 to 3, 3 to 4, 4 to 6, 6 to 8, and 8 to 9. So again, each and every node of a critical path are always equal. So now we have already completed the problem A and B, and Now we're going to proceed the last problem, which is to compute total floats and free floats for non-critical activities. So the total floats, it is the amount of time that the completion time of an activity can be delayed without affecting the project completion time. While the free floats, it is the amount of time that the activity completion time can be delayed without affecting the earliest start time of immediate successors activities in the network. So we can compute the total floats and free floats from the given formula. So in total floats is equals to the latest completion time of ending activity minus the earliest start time of starting activity minus the duration. And free floats is equals to the earliest start time of ending activity minus the earliest start time of our starting activity minus the duration. So this is the summary of the total floats and free floats. So as you can see, I have already calculated the total floats and free floats, and I am just going to discuss to you how I calculated it. So according to the formula, in finding the total floats, latest completion of our ending activity minus the earliest start time of our starting activity minus the duration. So 8 minus 0 minus 2 is equals to 6. So therefore, in our activity here, our total floats is 6. Now in free float, according to our formula, the earliest start time of our ending activity is here, and our earliest start time is 2, minus the earliest start time of our starting activity is 0, minus the duration. So 2 minus 0 minus 2 is equals to 0. So in the same way, in activity B, so 5 minus 0 minus 5 is equals to 0. And free floats is 5 minus 0 minus 5 is equals to 0. So that's how to compute the total floats and free floats. So take note that any critical activity will have 0 total floats and free floats. So now let's check our critical path. So activity A, this is not the critical path. B, yes, 0, 0, so this is our critical path. So here, B. And D, 0, 0. And H, 0, 0. And K, 0, 0. And last is N, 0, 0. Now let's check if our critical path here is the same critical path that we calculated earlier. So here, our critical path is here. Activity B, D, H, K, and N. And here, B, D, H, K, and N. So therefore, we calculated correctly. So therefore, our critical path is B, D, H, K, and N. Activity B, D, H, K, and N. 1 to 3, 3 to 4, 4 to 6, 6 to 8, and 8 to 9. So that concludes my report today, and I hope that you learned from me about the critical path method or the CPM and networking schedule. So again, this is Marian Piquiquiabo, a Master's of Business Administration 1.